So you watched the tutorial on unit testing and the examples there weren't quite satisfying. Well, because you watched the tutorial, it has a simple example, you come back to your code, and it has a little bit more dependencies, right? Maybe you're dependency injecting an interface and then you're calling a database, or you're making an HTTP call, and then suddenly unit testing is kind of like, right, how do I do this thing again? And you go back to the YouTube video. Hopefully you find this one, because I'm actually going to explain to you what is mocking and, why it exists, right? So in a service like this, when we create something, we put something in here like a time span, okay? So during creation, usually we want to put in services that would resolve a time span. That way we have an unlimited ways of resolving a time span because it sits behind an interface. So general example, super easy in the previous tutorial. If you haven't watched it, link in the description. Today we're going to start off easy by looking at a service that depends on an interface, and we're going to understand what mocking is. And we're also going to look at mock-Q. There are other libraries there that help you mock, although I never needed anything past mock-Q, so we're just going to take a look at that. So here I have my create something service. We're going to have create something tests here, and let's take a look at what we got here. We inject some kind of store, so a database, something that is going to save stuff. We don't really care about the actual saving, we care about this logic here, okay? So if something is valid, so this is C#9 pattern matching, I'm making sure that it's a not null object where the name is of length more than 0, right? So I'm doing some validation. And what I'm really interested in is, depending on whether we pass validation or not, I'm either going to get a successful result, right? So a success turned to true and error empty, or the other way around. I'm going to have false and some kind of error, okay? And then there's also some kind of package that we pass in here, which is the something that we're checking, okay? The important bit here is the logic. The not important bit here is the saving to the database. Although we don't want to test the actual interaction with the database, we want to make sure that this is something that's been called, or make sure that this gives us some kind of a result back that we expect. So let's go ahead and take a look at what mocking is. Mocking is essentially when your service depends on other services and you have separate tests for those services. You don't want to rewrite all the conditions that you wrote for those services for this other service that just depends on those services, right? In this service, all we're going to do is we're just going to say, right, we're going to expect those other services to do something in order for this service to function in a specific way, okay? Let's go ahead and see how this looks like. So let's go ahead and test this validation. So let's just grab create something result. We'll create our fact. I'll say public void create something result not successful when invalid payload, right? I'm not going to say invalid something. I mean, you can say invalid something, not that. It's nearly bleeding off screen, so let's cram it down a little bit. Maybe if I swap, never mind. So as I said in the previous video, your test, you're not trying to take this and cram it into the test here, right? Just to arrange it in slots. What you're doing is you're writing a program that is consuming your class, all right? So as if you're going to be writing a front end, or you're going to be writing some kind of client that is going to be calling your API, you're doing the exact same thing. If you want it to work on the front end, you need to essentially create a client that will do the same actions as your front end, but here, all right? That's essentially what unit tests are. You're testing the application programming interface, API, for your classes and interfaces and so on and so forth. In here, what we're going to need is we're going to need an instance of this create something. So let's create a variable. We're going to import this thing, create something, and we'll just create new. In here, what we will need to do is we'll need to supply this interface. Usually, if you're not using a library like mock-Q, you would go ahead and create your own fake implementation in order to test this. So we'll create a store mock, okay? And let's go ahead and make this, create something store mock, yep, public class, okay. And let's implement the interface. So here we have save, a specific thing that we wanted to return. If we are going into this clause here, it will have to return true, because if something fails on the database side, it's going to return false. So at that point, maybe we want to handle this condition in some way. At this point, I mean, this is just an example, so it's a boiled down explanation. What we're trying to do here is achieve a mindset. So at the moment, we'll just return false, because that's the only thing we need for this condition. I mean, we don't even need to call this save, right? We can leave it as not implemented. And all we're going to do is we're just going to go ahead and pass a store mock in here. We're going to create something. We're going to create, let's see, we will have null as one of our conditions for it not being valid. You can use theory, enumerate all possible objects that are invalid. You do that in your own time. Here we're learning about mocking. Okay, so we create a null. We are expecting a result, right? Create something a result, all right. And let's assert it's gonna be false, create something a result, and success, right? Generally, I would say do not test the messages that you're outputting. If your application ever grows to essentially being an international one, so you're going to be giving out errors in different languages, you're going to need a service here that is going to be resolving the error depending on what language your user speaks in, okay? So I would say don't test against these. These are going to make your test a little bit strongly dependent on this string here, rather than a configurable error based on whatever. Let's go ahead and run this test. Cool. So there we have it. We have, we're not really using this iStore. We don't really need it for this condition, right? Although we can take some steps to ensure that we better not call save when this is invalid, right? So if we have all of these conditions invalid, we're not really making sure that this is not being called. Okay, so even though this returns false, let's say we did call save, but it failed, so there was an attempt to call the database. So here is what you might do. Let's go ahead and create a prop int call attempts, or let's say save attempts. It will always start at 0, and we're gonna go ahead and increment here. What we will do then is we will take out our store mock, var store mock, right? There we go, store mock, and then we're going to assert that this should be 0. Now our store mock, save attempt. Okay, we should not be attempting to call this function at all. All right, so this is how we're checking and making sure that even if something here changes and the save is false because it's by default here, we're making sure that we're not calling save. So there is no attempt to save to the database when the model is invalid. Okay, let's go ahead and run all the tests again. I mean, we're not really bothered with the basic ones, we're bothered with those ones, so let me just remove those, and from now on I'm just going to be running these like this. So create something result not successful when invalid something, and I mean, I don't like these to be too verbose. I like them to kind of be a little more to the point. So usually when I name my tests, I don't try to make them concrete to these objects here. Yeah, let me just show you an example. A name, so doesn't save to database when invalid something. When something is invalid, whatever, it doesn't save to the database, right? So it's more of a human sentence rather than dependent on these objects that programmers have thought of, like create something result. You're not putting your constructs into conditions. You're giving it a sentence that some person in your business would say, right? So that's just a little bit of a tip on naming your tests, or my perspective on how they should be named. This is one condition. Then let's go ahead and create another condition here, just a different one. So this instead will save to database when valid something, right? In our case, it's going to be var something equals new, let's see, create something, and we'll need to give it a valid name. So foo, something along the lines of that. Something. And there we go, right? And now we go ahead and call it with this something. This should be called once. This should be true, okay? this should be true only if this returns true as well. So now what we have to do is we have to mock the result of this as well. Okay, so in store mock, what we can do is we can say, copy this, bool, save result. All right, put this here. By default, this should be false. But here what we're doing is we're setting it up to be true. All right, and because it's true, we can validate it, we cannot validate, although it is important to validate it because we do set the result from the result of this function, so it is important. And also this test, let's name it something like this: saves something to database when valid. So this infers that we're saving something to the database, and I know that this explanation is very tight to this example, but the fact that we're putting something in the database, or we're attempting to save something in the database, kind of ties it to this whole, this whole example that I'm trying to do here. So it's important to verify that the object that we've put in here is the one that's being attempted to save by this function. All right. So this is where we can grab create something and we something, and we would say last saved object, right? Because we can only store one of those somethings. Last saved, not object, but let's say something, right? So let's save something, and now we can actually do is we can verify that by reference that the last saved something is indeed the thing that we're passing into this function, right? So hopefully you understand the problem here. If you're mocking an interface and you have way too many functions, you're going to have an increasing amount of properties. You're going to, have to create your own mocks. I mean, this class, you're going to have an explosion of these mock classes. Sometimes you can't avoid them for certain services, but hopefully you can see a problem and a bit of a tediousness associated with maintaining these classes. Okay, this is where mock Q comes in. Let's go ahead and see how it helps us solve this problem. Let's go into packages. We're gonna type in moq. We're gonna grab this and we're gonna add it to our mocking solution, right? So if you're in Visual Studio, right click on your project, manage NuGet packages, search for mock and add it. So there it is, added for me. What you want to do now is you want to create a mock, a generic type mock that will contain your interface that you want to mock. Okay, let's just import this and whoop, we will call it something like store mock. No, actually store mock. That'll be fine. Yeah, for the name. Generally, this is okay to be a property, a global property, so we can name it read only, and we can also just give it a new whatever class, and that is just fine. What we want to do now is we want to just replace what we have here and have the same checks that we had. So because we're creating this as a global object, understand that you get a new class for each of your tests with XUnit. If you're doing this for NUnit, just be careful, you might need to put this inside the scope of your test here, right? But anyway, store mock, how do we use it? Instead of going ahead and creating this implementation, it does it for you, and you're essentially getting this class implementation from this object. Okay, it creates this object for you, and then it tracks everything that you do with it, and you can also set it up to do certain things. Okay, so let's just take a look at what happens here. So we no longer need to instantiate our store object. mockq does it for us, and then the verification, the assertion, happens within here as well. So store mock, what we want to do is we want to make sure that save hasn't been called. So we call verify, we call the function that we want to verify that hasn't been saved, right? Now we have passed null in here, so we can try to say it doesn't really matter that this is being called with null or not, so the same sort of object. You can keep null here, although what I would recommend is the type that is meant to be going in here, which is this something. I would say widen your check. Nothing should be able to be go in there, and we use this by using the it static class with some static functions in here, where we can say that whatever is going in here is anything of a certain type. So here is where we would grab this type of create something. We would put it here, right? So let me just pull this over here, And there we go. And we verify that the save with this type that's going inside of it is not going to be called at all. So past here, we'll say times and never. So this should never happen. Okay. So this is rewriting the first one. Let's take a look at the next one. Again, store mock. We no longer need to create it. All we do is, again, we just pass the store mock. It's the store mock object. We then need to go ahead and set up the result of this function. Okay. So what is going to happen here? You can do the setup step. So kind of like verify, but here you have setup. And you can, this is a very flexible tool. So you can do, if you're calling the same function multiple times, there's ways to set this up using mock queue as well. Understand this is just the beginning, the basics. This is just to understand what mocking is and how mock queue does it. It makes it easier for you, okay? So again, we're going to say setup save function. We already have this something object that we're going to be trying to save. So let's go ahead and bring it up here. And we're going to say setup that when this save function gets called with this something object, we want it to return true. Okay, and that's what what it's going to return, right? So it's going to create this store mock implementation for you, and it's going to return whatever you tell it to return. Now, what we want to do is we want to verify this thing as well. This can be done in a combination of one. So let's go ahead and grab the store mock and we'll verify again. Here we're going to do the same kind of verification as we do here. All right, so save, save, but instead of passing anything, because we actually care that it's being saved, so we're going to compare the references. So we're going to put something in here, and here we'll just say ×1. So it's gonna get saved once exactly. Okay, there we go. Let's delete those two and let's run our tests again. I just run all tests, but well, whatever. They're pretty quick. And there we go. Hopefully you can see the benefit this class now goes. Okay, although I will leave it in here for educational purposes. Okay, so just to recap what we've just done, there are two tests, and primarily we're testing two things that can happen, right? You can literally see the branches: one condition, second condition, two tests. There is a multitude of things, all possible edge cases you can test this if statement for. This all goes into theory into this test, right? That is more specific to how you would expect to use your class, your service, right? If that is some kind of a mistake that your user can do, or you've heard your user do, or you're scared that your user might potentially put something wrong in the input field, that is when you need to test that condition on the front end and on the back end. So, you know, your application doesn't fall over. You don't want to get called at night and be like, oh, this is broken. Why is this broken, right? Let's go move on to a few more examples here. I'll close this. And from this point on, we're going to continue using either mock queue, or I'm going to show you how to mock certain things, okay? And how to really come up to a solution, right? Okay, next example, intranet communications, right? A lot of people ask me about how to mock I/O, generally with HTTP and calling third-party services. Unit tests do not call I/O, do not test I/O specifically, mock it and make sure you are basically imagining, you're hypothesizing. If a third API is going to work this way, then my application works this way. That's what you want to do. Integration testing, I would still argue, because it's not like full production. You don't have 100% replication of your environment. Still try to mock third-party integration. Still try to mock the HTTP clients, unless the third party or the API that you're calling it belongs to you, and you can reliably stand up a test environment and mock the things there as well, or like see the database or whatever, so you can you know, have an expectation of what it returns, a consistent expectation. Otherwise your test will break. It's not a good, it's not a good experience. Okay, system testing, this is what I would say you want, because the third-party services, they generally only provide a live environment for you. This is where you have two live environments if you can afford it, okay? And you have one live environment for your system tests, where you have an API quota, where it's specifically for your staging environment, right? So you stand up your whole staging environment, you run the system tests where you get real results, that you maybe check the form of the results, so the response matches, you got these fields, because you can't really hard code the results because they may change all the time, so that you still have to be a little bit creative when it comes to that solution. But system testing is where you want to really test the integration. We'll come to that, but because we're at mocking, we're still at unit test level here. And still, if you're wondering, at system level testing, you still might want to mock third party or not test it at all. Reasons for we're not going to get into, but understand that it's not too bad of a thing if you're not 100% testing everything. Okay, some manual testing may be better than automated testing. Now, anyway, let's come back to here. We have an HTTP client. How to mock an HTTP client. So if you've never done this before, what I want to get out of this session is to really understand the process of finding out how. All right, look for virtual, abstract, protected methods like that you want to override an interface or services that you can substitute in there that are being used at the core of the HTTP client, right? So we have an HTTP client. We are calling get from JSON async. Let's go ahead and see where we can, like, you know, swoop in and be like, we want this and we want to change it, right? Anyway, let's take a look. So get from JSON async, I will extend this a little bit. These are all extensions. Skip through these, look for protected override if you can. These are all static functions, so just make sure that you look at where you're going next, so you don't skip over something like client, HTTP client get async. That seems like a vital step in the call chain. So let's take a look at that. Here we have get async, still no virtual, no abstract. Get async, send async, and then we send async core. All right, so in send async core, this is a big function. Again, step through it one by one. Eventually you will come to the initiate the send, and then on the base of the function right here, base send async, is where something along the lines of this will happen, right? Again, we'll check, and then we'll return with the handler on send async. This is virtual, right? So we have two options here. We override this bit, or we substitute this bit, okay? So let's take a look at what we can override. Now, there are some things that you gotta watch out for. Let's first try to override this function here, because then we don't need to account for anything that happens here, or something that we might need to handle, okay? So HTTP message invoker, the class that this is happening in, is what HTTP client inherits from originally, right? HTTP message invoker, there it is. This is where the send async function happens. So let's create our public mock HTTP client. Let's inherit from HTTP client. Oh, HTTP clients right here. And obviously this is a class. I already, just forgetting to write classes and stuff. Let's just override our send async function. We will remove the base because that's not what we're after. Although one important thing that you can check at this point is trying to go into the send async function, because base.send async function, this will verify that you're overriding the correct thing. Okay, let's go in here, and this is where you will see something interesting. We're essentially overriding a function that is on the HTTP client, because this is overriding this send async function on here. Okay, although when we go through our HTTP client, extension, the JSON extension functions, when we traverse this, we never seen the virtual function, although I'm pretty sure, yeah, it's something here. It's so we never pass the overridden function, all right? So if we try to mock this, we wouldn't actually be able to substitute our result, because we never go through this function, all right? We'd never go through this particular function. We end up in this HTTP message invoker. So sometimes in order to mock, you really have to dig in and take a look at what's happening. We can now take the handler and override the handler, okay? So instead of mocking the HTTP client, let's mock the send async, which looks bizarrely identical to the HTTP client that's send async. And I mean, it's named the same as well. So let's just take the HTTP message handler. It's protected internal abstract here. So let's go ahead and inherit from it. What we're going to do is we're going to need to change this to protected. Let's go ahead and return not return that. All right, let me put these on new lines so it's a little bit easier to see. Let's go ahead, close this. Okay, intranet communications, let's put this back here. And we will be grabbing an array of strings. So let's go ahead and return task from result. We will, simulate a little bit of JSON, like that, and then like that, right? So names foo bar, and one more. Why not? One more, right? Baz. There we go. And obviously these need to be on a new HTTP response message where we gotta set some content, and this will have to be new string content where we can put the string. Okay, cool. So there's our mock HTTP client. Let's go ahead and create the names here. So public fact void fetch names fetches names. Yes, good test is good. Let's go ahead and create our icon. So our new intranet communications class right here. When writing up these examples, I didn't really think how how appropriate they're gonna be. Although I probably should have thought about it. Never mind. Right. That's not the point here. The point here is that we know how to explore other classes that we haven't written and seeing where we can like come in and substitute things. All right, let's go ahead and put our new mock HTTP client, although this is now a handler. All right, let's go ahead and give this our client. On the icon we can then fetch names. Cool. Let's grab our names. We'll need to wait on this. We'll need to make this task, and let's go ahead and assert equals. I'm gonna actually to list this like that. Now let me scroll down a little bit here. 3 names count, so check the count, and then let's go ahead and check contains for foo bar baz. Okay, cool. Let's go ahead, try run this, see what happens. And there we go. So you get an error, an invalid request URI was provided. So we can should we let's substitute this from our test. Okay, new URI. So I can never write these things. And there we go, right? So substituting third-party clients for your unit tests. Here, all you're doing, again, you're just trying to use your application and just imagine, okay, if third-party thing behaves this way, this is how I want my application to behave. This is what I'm expecting to happen, okay? Make sure you cover certain scenarios which are valuable to you, all right? If you don't know what's valuable to you or you don't know how to decide, watch my previous video, link is again in the description, right? Cool, let's get moving. We're not gonna stick around too much on that one. Next thing, don't test Microsoft API. So let's talk a little bit about the file stream. So kind of like the HTTP clients, where what we're really interested in is the data that it returns, not whether the HTTP client works or not. HTTP client is given to us by Microsoft. Microsoft are going to test it. It's like depending on your third-party API. You're not going to be writing tests for Google's API or whatever, or Facebook API or whatever other API in your test suite. You're going to mock them. Same thing happens here. Do not test the HTTP client specifically, that it serializes and sends stuff and whatnot. Do not test the file stream, okay? Do not test other people's APIs. Do not test Microsoft's API. Be careful. Do not get stuck in this loop of testing classes that are given to you by others. And by testing how frameworks work, this is specifically important in ASP.NET Core, where everything like the framework is all around you. Do not test the framework test your code, right? This is why you take your code outside of the actual ASP.NET Core application, the server, so you can first plug it anywhere you want, and so it's testable outside of that environment, okay? So anyway, we take a look at a test like this, and it looks like I already messed this up a little. I was meant to put a path like that in there, but anyway, how do we test this? So this is a bit of a problem if we have an implementation that does anything like this. So if it news up a object of some kind, we have no like way to get into the function, you know? The function, the scope, protects this new keyword. So we cannot come inside of this function and be like, yo, instead of this new that you're doing here, do this mock thing that we're trying to do, right? There is no way to do that. There is no way for us to come into the open write because it's a static function, and inside of it, it's doing this new thing. A bit of a problem. It gives us back a file stream though. We need to refactor our code. So file stream, let's go ahead and create a constructor here. What we're going to do is we're gonna try, again, in unit testing, it's not important to test that you're actually writing the correct file to the correct thing. Integration testing, maybe it's appropriate. Sometimes I would do more database interaction at integration testing level. System testing is where I would say, right, this is where files are important to be tested, right? Otherwise, integration testing, you kind of want to still run it quite often, so you don't want to do a little cleanup and stuff like that, right? Anyway, moving on. We have a big symptom that is popping out. We can't mock it, and the specific thing that it is third-party functionality that's already robust and tested. We don't want to test it again. And it has a new keyword, right? So we can't mock it. That's the main highlight here. It's impeding us from testing this. So this whole thing in and of itself is a kind of service to mock it, but imagine that there is more work that happens here, right? More work. And more work here, okay? At some point, we open it, check the more work, and then we write to it. So iFiles, I'm just gonna make up this interface on the fly here. Let's go ahead and generate this field. And what we want to do is we want to get ourselves a file stream. The thing that this returns, if it's important, if you can go lower down, the less that you have to, because file stream basically internally inherits from stream. So if you can make it return a stream, do that. Okay, otherwise go to where you are right now. If you can go lower in abstraction, do that, or higher in abstraction. Anyway, let's say open write stream to string path. Okay, and the good thing is if the file stream or whatever C# API changes, you just go and change it in one place instead of changing it anywhere that these dots are seeded, kind of thing, right? So anyway, that's the implementation. What we do now is we go ahead, grab our files, right? Whoa, okay, it's static, right? We no longer have this static. Files, write stream to, and path. Okay, implementation. So you hide that thing behind this interface here, which you inject, and the implementation lives there. So that function will still live there. It will be a really small sort of indirect pointer sort of thing. But what this allows you to do now is this allows you to mock your test. So let's go ahead and do something along the lines of public void write to file stream, and then you have your whatever conditions, right? Again, this is not so much specific. This is not so much about the testing the work around it. This is much more about not depending on that third API and being able to take that code out of your service, hide it behind the interface, and basically realizing where a struggle point, where the blocker is in your code to prevent you from testing it, okay? The condition of writes if valid, whatever, that thing isn't important right now. What's important right now is testing this bit here. Okay, so for this exact reason, this test is going to be a little bit redundant, or is going to feel redundant, as in stupid and doesn't make sense. Although once you have the logic around it, it really allows you to take that functionality out of your test, ignore it, substitute it with something simple, right? I'm expecting to get this, or I'm just expecting this to get cold. So in here, what we will do is, let's just put an underscore here. We'll do a little bit of setup for the open write stream. So open write stream 2, we'll say path, some kind of path. Going to use, so I'll say new file stream, extend this a little bit. And this is usually when it's better to take it down. So if you take this down to a stream, which you can still write to, this will give you a little bit more flexibility in terms of writing it to a memory stream, writing it to a file stream, because now you have to supply a file and so on and so forth. But if you have a memory stream, that might make everything a little bit easier for you in order to test it and make your iFiles service even more flexible, right? So let's just remove that bit there. So we set up to grab this memory stream there. Let's go ahead and create some kind of our service. Don't test Microsoft API here. File mock the object. It doesn't matter if you set it up after or before you pass it, by the way, in case I haven't mentioned this yet. In our service, we will save a file. We'll save to path, and we can pass another memory stream here. And I'm gonna wing it a little bit, but I'm not entirely sure how this stream. Let's see, a byte buffer. See, new byte array. We'll do something like 2, 2, 2, 2, 2, 3, 4, and commas, obviously. Don't forget about commas. 5, right? A good amount. So we're gonna take this stream and make sure that it's written to this other stream here. And I guess it will be important to check it later. Memory stream. Let's go ahead and save file. I think let's just wait on it, because that's just something that happens here. And at the end, assert that equals, how many, got 4 there, memory stream length. I'm guessing that might be okay. All right, and there we go. So we give it a stream to write, it writes it to this stream. Again, we are more or less testing that these objects are being used, or we're expecting it's going to give us some stream, and then we're going to do this work with this stream. We're not actually, some of this test relies on the memory stream and streams working internally. So again, try not to test the API. I would argue that this test still tests the API more or less, because what you really want to be focused on is testing this more work around here, right? So you want to test the stuff that you wrote, and for the other stuff, you just want to kind of make sure, okay, it will do this other thing, broadly speaking, write a file. Writing a file as an operation involves transferring bits in these chunks over this period of time with this extension, and putting this header, whatever, right? Writing a file is a little bit more involved, as we know it for the testing purpose. It's going to try to write a file using this interface, or it's going to copy some memory from here to here, right? We don't necessarily need to test this operation. Let's go ahead and take a look at the final example here. Property hash, the second example from the previous video. What we're going to do here is we're going to rewrite it a little bit to make it a little bit more testable and a little bit more reusable, okay? So I guess this is just a cleanliness approach and just a testability approach, right? So before we had a property hash, we inherit from a property hash, and this higher service depends on this property hash service as well. So direct dependency, or you're kind of trying to override it, and then we are inputting what kind of algorithm we want to hash with. So upon dependency injection, that's when it will have to be decided what algorithm it is, or when we resolve this service. This is not the best way to resolve this service, as the resolution, the creation, so if you have creates, if you have new in your constructor or anywhere within your service, you don't have it outside. If you don't allow the outside thing, basically say what we want in this thing, then you're basically already losing out on composability, usability, etc., right? It might feel like a little bit more work on the outside, but it gives you flexibility. Okay, so let's go ahead and see how we can do this. This is giving us a hash algorithm. So public interface hash algorithm refactoring. All right, there we go. Hash algorithm, create, and there we go. All right. The thing that implements is going it is going to like basically decide what it's going to return. So it's up to the implementation of this bit. What we do here now is we go ahead and say algorithm factoring. All right, we can remove this bit here, this bit here. Let's make this thing here. Factoring, create, and compute hash. And now we no longer need to dispose of this here. We would rather maybe do a little using statement. Right? Using our algo equals algorithm hash create, right? There we go, hash bytes. All right, and maybe let's just let's give ourselves a using statement here, right? There we go, and at the end it will be discarded. So there is one bit there. Let's remove the iDisposable. Now we have different ways to specify the factory for what we want to use as our algorithm. So it now hides behind an interface, and because it hides behind an interface and not just a string, we can now put some kind of additional operations in there. It can be a whole blown service, check the database, check the cache, if this, that, and whatever, do the other thing, right? It's just an explosion of possibilities and what we want to do with it. Not the point is, yeah, I mean, that's the point. We want the flexibility. Now, a second thing that might not be so apparent is when testing this, property hash, this algorithm property hash, you've already written tests for property hash here, and this property hash has been tested. All those tests can now kind of be ran against this or this property hash here. There is no need to do this inheritance, or I guess if I put a semicolon here first, what I'm saying is you're already testing this, that this is doing its own thing. By extending it here and by giving it additional functionality on top, you have hidden away the things that you've tested behind the class, right? You still want to test in this class the thing that it's doing. So the thing that it's doing is this much. This base hash right here is the previous thing. Inadvertently, this thing here is going to impact your tests here. So instead of an inheritance approach, what you'd rather do here is a composability approach. So that being said, let's remove the property hash. We'll remove the override. We'll remove this bit here. And now we'll depend on the seed instead. So now we can use this separately. All right, so we separated from this hashing strategy. So this is where we can now test this specific functionality. We don't make it depend on this specific way of hashing something just by concatenating all the selected fields. What we're doing here now is testing this specific hashing algorithm. Hopefully I'm not rambling on too much, and you can see the point that we can not just supply a property where we have to supply a property with selectors, we can just supply a string. So if we want this functionality inside before this, we just create this class, we do generate our little hash here, and then we pass the result of the string in here, okay? Sometimes just understand that inheritance may look like you're reusing functionality, you're making your code clean, but in reality, you're creating some coupling that is actually hindering reusability of your code. And if your tests sort of the parent, you have one test testing the parent, and then you have the second test that requires sort of the test of the parent to be included in the test of the child, that can be a big symptom of maybe you are losing out on composability and you're doing inheritance slightly wrong, okay? So we're not going to be writing tests for these in the interests of time. It's already been quite a long video. This will be it for this video. If you enjoyed it, leave a like, subscribe. If you have any questions, as always, leave them in the comments section or reach out to me on my Discord server. Source code is in the description. I also stream on Twitch Wednesdays and Sundays. Link in the description as well. Everything's in the description. Anything you probably ever want is gonna be in my description, so make sure you read those. Hopefully, I'll see you in my other videos.